The more we discover about exoplanets, the stranger the universe seems. It's hard to think that no planet outside our solar system had been discovered until the early 1990s. Until the finding of 2 extrasolar planets around the pulsar, scientists had scant evidence of additional planetary systems. Alexander Walskson and Dale Frail discovered PSR 1257 plus 12 in 1992. In 1995, astronomers Mitchell Mayer and Didier Queloz discovered 51 Pegasi b, the first exoplanet discovered near a Sun-like star. Exoplanet discovery has accelerated since 1995. NASA says we now have over 4,000 confirmed extrasolar worlds, with another 7,000 or so planets awaiting classification. These discoveries are still in the early stages of development. Let's take a look at some of the most dangerous planets that have been discovered recently. Number 10. WASP-76b, the exoplanet that rains molten iron. WASP-76b is a tidal locked planet discovered in 2013 and studied by the Espresso instrument on the Very Large Telescope in 2020. This means one side of the planet is permanently facing the star, resulting in blistering temperatures of 4,532 Fahrenheit, which is 2,500 Celsius, hot enough to melt an iron. Its star-facing side is scorched by radiation thousands of times stronger than that Earth encounters from the Sun, while the star-away side is perpetually dark. Even while the day side of the planet is scorching hot, that doesn't mean the night side is much warmer. The side of the exoplanet that faces away from its parent star is cooler by at least 1,832 degrees Fahrenheit is 1,000 degrees Celsius, but vigorous winds temper the iron vapor, generating liquid droplets. The molten iron rains down on the planet's cooler side. WASP-76b may not be the only planet that gets these horrific rains. As is often the case with exoplanets, new findings make things even odd. Both NASA's Chandra X-ray Observatory and ESA MXM Newton X-ray telescopes identified the exoplanet in 2005. Its supersonic winds enable glass raindrops to arc sideways rather than fall, scooping up silicate particles and converting them into minuscule missiles. NASA reports that the massive exoplanet has a significantly greater atmosphere than scientists expected. Number 8. Gliese 1132b, the planet that grew a second atmosphere. Gliese 1132b is strikingly similar to Earth. Its radius and mass are slightly bigger. Its age, 4.5 billion years, is close to ours. But this world has one notable distinction, that is, it orbits its red dwarf parent star in just 1.6 Earth days. Its surface temperature is 278 degrees Fahrenheit due to the intense radiation eroding the exoplanet's atmosphere. But astronomers have discovered something unusual on Gliese 1132b. Its star's gravitational pull causes enormous tidal forces that squeeze and expand the planet. This flexing triggers severe volcanic activity as gas rushes to the surface. NASA claims these gases are creating a second atmosphere. The regrown atmosphere provides astrogeologists with a rare opportunity to analyze the interior chemical makeup of an exoplanet by proxy. Number 7. Kepler 10b, in a galaxy far, far away. Kepler 10b orbits its host star, like the Sun, at a distance a 20th of Mercury's orbit. Because Kepler 10b is tidally bound to its star, it produces molten iron and silicate droplets. Lava far hotter than Earth's likely covers the planet's surface. The atmosphere has been stripped away by its host star's severe radiation, so these droplets are pushed away from its surface by stellar winds, giving it a blazing tail. The Kepler telescope has found several lava worlds. It's no surprise that these exoplanets have been likened to Mustafar, the Star Wars world where Obi-Wan Kenobi and Anakin Skywalker fight with lightsabers. Number 6. Upsilon Andromeda B, a world of fire and ice. Upsilon Andromeda B is yet another exoplanet that orbits its home star in under 5 days. The huge temperature differential between the day and night sides of this planet, formerly known as Sapphire, makes it an extreme world. The day side reaches 2,912 Fahrenheit, while the night side drops to -4 Fahrenheit. This indicates that crossing the world's hemisphere is akin to diving into a volcano. NASA says the extreme temperature differential could be attributable to the parent star Upsilon Andromeda A's massive magnitude, or a hot point virtually right overhead the exoplanet. You may get the notion that all exoplanets are fiery, violent worlds orbiting their parent stars. An orbiting planet's proximity to its home star facilitates detection. Large worlds with tight orbits are abundant in the exoplanet catalog, but there are notable outliers. Number 5. HR 5183b, the Whiplash Planet. HR 5183b, a super-Jupiter, 3 times the size of the Solar System's largest planet, is notable for its very eccentric orbit. Unlike other planets, this gas giant's orbit around its parent star, HR 5183, is egg-shaped. The exoplanet was identified by the slight motion its gravity causes on its parent star, causing a decrease in brightness. Researchers estimate that it will take between 45 and 100 Earth years, probably 74 years, to see the globe complete an orbit. So, if HR 5183b were to follow its orbit in our solar system, it would travel closer to the Sun than Jupiter before swinging past Neptune. A world's loose affiliation with its parent star may surprise you, but other worlds have gone much further, completely dissociating from their parent stars to roam the universe alone. Number 4. Augle 2016 BLG 1928, Going Rogue. They think the Milky Way is full of cosmic orphans, exoplanets that have broken away from their parent stars to traverse their galaxies alone. These planets are thought to develop near stars but are blasted away by other planets' gravitational interactions. Exoplanets are usually detected by their effect on their host stars, making homeless planets difficult to detect. This is particularly true of Earth-sized rocky planets. It's not the first rogue planet found, but it's the smallest, with others equivalent in size to Jupiter. Gravitational microlensing detected the stray terrestrial world in late 2020. The period of the shift in the light profile of distant sources rises with mass. In fact, it was the shortest road ever detected using this method, lasting only 41 minutes. Number 3. The TOI 178 system, a system of harmony and chaos. At first inspection, the TOI 178 planetary system appears ordinary. Closer inspection indicates that at least 5 of this system's 6 worlds are engaged in a rhythmic dance. The planets orbit their orange dwarf host star at regular intervals. That a planetary system hasn't been perturbed by gravitational effects or crashes with other systems. Since its creation is probable based on this intricate chain of researchers studying planetary systems, the system could be vital. Where there is order, there is often anarchy. The TOI 178 planets' compositions lack the harmony of their motion. A puffed-out low-density planet follows a dense tropical Earth-like world, followed by a Neptune-like exoplanet. Number 2. 55 Canari E, the universe's most valuable exoplanet. This exoplanet takes less than 18. Scientists believe 55 Canari E is made up of high-pressure carbon in the form of graphite and diamond, combined with iron and other elements, according to NASA. When protoplanetary dust storms with high carbon ratios collapse to create planets, diamond worlds may occur pretty routinely. Since the exoplanet was discovered in 2004, the assumption that 55 Canari E is formed of diamond has been disputed, proving diamonds may not be everlasting. Despite these extreme worlds, the most unusual exoplanets may still be out there waiting to be discovered in systems we have never encountered. Number 1. Planets, black holes, extreme exoplanets. Extreme exoplanets may originate around supermassive black holes rather than stars. Supermassive black holes at the core of active galactic nuclei lie at the center of enormous swirling disks of such materials. Recent research modeling the dynamics of these disks of gas and dust suggests that under certain conditions planetary formation should occur in such locations. If this happens, planets will form far further away from supermassive black holes than most planets do. 1 million years could be required for such a world to make one orbit. The AGN radiation may offer a steady supply of new material for planet creation, leading to runaway formation and planets reaching titanic sizes. planets are less likely to be like Earth or Jupiter, opening up new astronomical classes beyond gas giants and habitable worlds. Because the nearest AGN is beyond the scope of current exoplanet research, planet detection may have to wait. Exoplanet discoveries will continue to test our developing understanding of the cosmos and change our place within it. What is your thought on this one? Do you know of any dangerous exoplanets that we missed in this video? Let us know in the comments below. If you want to see more interesting videos like this one, do subscribe to the channel and press the bell icon to get VIP access to our videos. Thanks for watching everybody, and just before you go, make sure to give this video a like. And with that said, I look forward to seeing you in the next video. Take care.